Hello everyone, in this video you are going to learn about rational numbers, what are the rational numbers and the related concepts or properties. So I have a question for you. What makes a student capable of solving all the given questions in the exercise? The answer to this simple question is the understanding of the concepts and the different properties related to the given exercise or chapter. If you have better command on that, you can understand the solve all questions given in the exercise. So with that note, I'm Amit sir and you are going to learn with me the different concepts and properties of this very first chapter given in NCERT class 8th rational numbers. So please stay connected till the end of the video. If you have not subscribed the channel, please subscribe the channel for my motivation and do like and share. So let us begin with the very first point, that is what is a rational number. So how we can define a rational number? Simply we say that any number, the bookish language that is given in your book, any numbers which can be written in the form of p upon q, where p and q are integers and q is never equal to 0. So that is what the given definition in your book. So this is what we define it, rational numbers. In another language, you can say that rational numbers are the ratio of any two integers. We know that integers are the all positive, negative numbers including 0 on number line, and a rational number can be defined as the ratio of two integers, you can say, when two integers are written as numerator upon denominator, where the denominator b is never equal to 0. That means it is a rational number. If you are not able to write a number in the form of p upon q, a upon b, that means that number is called irrational. And such numbers we say root 2, root 3, which can never be written as the ratio of two integers, or you cannot write that in p upon q form. So you need to know about the irrational numbers also. These are the irrational numbers. But if we take some examples of rational numbers, so you can consider, you can have any two integers like -2 upon 5. This is a rational number. If I say one positive numerator, that is 3, and negative denominator, that is -7, it's a rational number. 1 by 2 is a rational number, 5 by 4 is a rational number. So any two integers you take in the form of a upon b or p upon q, that is rational number where denominator can never be equal to 0. So why denominator can never be equal to 0? This is because we know that if you write any number with denominator 0, so this becomes undefined. So we cannot define such numbers where denominator we have as 0, divisor as 0. So that's why we say that we give a condition to the definition of rational number. The denominator must not be equal to 0 in any condition. So this is what the rational numbers, all even numbers, odd numbers, natural numbers, whole numbers, which you have been studying since childhood, all are those rational numbers. If there is a natural number, that is 2, 2 can be written as 2 upon 1. So 2 upon 1 is a rational number. So this natural number 2 is a rational number with denominator 1. The value of q or b is 1 here. Similarly, you can write all the whole numbers as p upon q, a upon b, and we say that all whole numbers are the rational numbers. All natural numbers are the rational numbers. The rational numbers include all even, odd, whole, natural, integers. So I hope you got to know about the rational numbers very well. Now next, the very first property we have, rational numbers are closed under the operations of addition, subtraction and multiplication. What is the meaning of closed under addition, subtraction and multiplication? Addition means when you add two rational numbers, the result is a rational number. Suppose we take two rational numbers, 1 by 2 plus 3 by 2. These are the two rational numbers and you're going to add it. The addition is here 1 plus 3, that means 4 by 2, and the result is 2. So we say here the value 2 is a rational number because we can write 2 as 2 upon 1. So the result of the addition of two rational numbers, we have a rational number. Similarly, in case of subtraction also, if you subtract 1 by 2 from 3 by 2, in this case the result will be 3 minus 1 upon 2. We have the same denominator, so simply we subtract the numerators here. So this is 2 by 2 and the result is 1, and 1 can be written as 1 upon 1. So this is also in the form of p upon q, or you can say a upon b. Same is here. So subtraction and addition both, when you do with rational numbers, the result is always a rational number. That is why we say rational numbers are closed under addition and subtraction. And this is called the closure property. Closure property for the rational numbers. Now what about the multiplication? If you do multiply the two rational number, any two rational number of your choice, if you say 1 by 2 and minus 3 by 2, the result will be here minus 3 upon 4, and this is a rational number. The ratio of two integers, it's in the form of p upon q or a upon b. But what we can say about the division? Why division is not written here? Are the rational numbers closed under division? That is the question here. If you divide, for example, if you are going to divide 1 by 2 by another rational number, that is 0 upon 1, so you take the reciprocal of the divisor and then you convert the sign of division into multiplication, and you write it like this, 1 upon 0. In this case you get 1 upon 0, and this is not the definition, this is not fulfilling the definition of rational number because we have the denominator as 0. So we cannot say rational numbers are closed under division. So the very first property, now it's clear to you here, rational numbers are closed under the operations addition, subtraction, multiplication only. Now next, let us explore the operations addition and multiplication are commutative for rational numbers and associative for rational number. What is the meaning of commutative here? And then we will understand the meaning of associative also. So addition and multiplication, if you do add two rational numbers a and b, and you change the order of the written two rational numbers, you write b first and then a, and your result remains same, you say the property associated with this is commutative property. For example, if you do add, your a is 1 by 2 and your b is 3 by 2. So if you do the addition of this 1 by 2 and 3 by 2, your result will be 4 by 2, and that is 2 here. So either you write 3 by 2 first and then you write 1 by 2, the result will be same. So that's why we say that addition is commutative for rational numbers and multiplication. Now what about multiplication? You multiply 1 by 2 with 3 by 2, the result is 3 by 4. And again, if you change the order of writing these two numbers, you write 3 by 2 first, then you write 1 by 2, the result would be same, 3 upon 4. So we say the multiplication of two rational numbers are commutative. Now what about the associative property? Addition is associative. So if you do add three rational numbers together, you take A and then you have the grouping of B plus C, you associate B with C, and if you take B with A plus B you write like this, and C is left alone, your result won't be different. The same result you will get in both the cases of addition, by first one and the second one. This is what we call the associative property for the addition of rational numbers. And same happens with multiplication also. If you do multiply two rational number together, that is B and C, and then you multiply with A, so in that case your result would be same. You associate A with B and then you multiply it with C, the same result you will obtain. And in this case we say that the rational numbers are associative for multiplication. So I hope you have the clarity of both the properties here. Now next we have the rational number 0. 0 is the additive identity for rational numbers. So 0 is the rational number, and we also know that it's a whole number also, and all whole numbers are rationals because 0 can be written as 0 upon 1, and this is in the form of P by Q, or you can say A upon B, ratio of two integers, or in the form of P upon Q, both are same. So this is what the additive identity for rational number. What is the meaning of additive identity? When you add 0 with any rational number, suppose that 5 upon 3 you take and you add 0 with it, your result won't be affected. It will be 5 by 3 itself. Your number won't be affected, I mean to say. This is 5 by 3 plus 0, 5 upon 3. So you add it with any number, minus 3 upon 7 and plus 0. So the same result will be here, minus 3 upon 7. So this is what we call 0 is the additive identity for rational numbers, and additive identity is something which doesn't change the number when you add it. I hope you got it very well. Now next we have here the rational number 1 is the multiplicative identity for rational numbers. If you do multiply 1 with any rational number, that is P upon Q, you multiply, your result is P upon Q itself. That's why we say that 1 is the multiplicative identity, because it doesn't change the value with which you are multiplying 1. If you take minus 7 upon 3, you do multiply with 1, the result is minus 7 upon 3. So this is what we understand the multiplicative identity of a rational number, that is 1. The additive inverse of rational number A upon B is minus A upon B, and vice versa. So if you have a rational number A upon B, its additive inverse is minus A upon B. What is the meaning of additive inverse? You change the sign of it. If your rational number is positive, if you have a positive rational number, that is 3 by 2, so additive inverse will be minus 3 by 2. If you have a negative rational number, that is minus 5 upon 4, it will be plus 5 upon 4. If you have 7 upon minus 9, this is a negative rational number, additive inverse will be Additive inverse will be here 7 upon 9. That will be positive rational number. So this is what we understand from the additive inverse of the rational number. We simply change the sign, positive to negative and negative to positive. The reciprocal or multiplicative inverse of the rational number AB is B upon A. So if you have any rational number that is A upon B and you find the multiplicative inverse or reciprocal of it, it is B upon A. What is the reciprocal of 7 upon 8? This is 8 upon 7. That is the reciprocal of 7 upon 8. If you have a rational number that is minus 5 upon 8, what is the reciprocal or multiplicative inverse? It's 8 upon minus 5. Or you can say minus 8 upon 5. This is what you write. So this is what we understand from the multiplicative inverse of the rational number, where we make the numerator denominator and denominator to numerator. Distributivity of rational numbers for all rational numbers A, B and C. If you do multiply A with the sum of B plus C, then you distribute it and you write it AB plus AC. And if there is subtraction of two rational numbers within the bracket and you do multiply with another rational number, you distribute the bracket in two parts, that is AB minus AC. So we can understand it with some example here, distributivity of rational numbers. So we take an example. 3 upon 2 is to be multiplied with the sum of 5 upon 2 and 3 upon 4. So we know that we can solve the bracket here first. We can do addition and find the result of 5 upon 2 plus 3 by 4. And this way we can multiply the result with 3 upon 2. But using the distributive property of rational number here, 3 by 2 is to be multiplied with 5 upon 2 and then 3 by 2 is to be multiplied with 3 by 4. And your result is here 3 5s of 15 upon 4 and then you have 9 upon 8. Then you can take the LCM, 4 and 8, the LCM is 8 here and 4 goes 2 times to become 8. So equivalent of 15 upon 4 is 30 upon 8, and then we have the same here. Number 8 is here with 9 upon 8. We have the denominator 8, so it would be simply written as 9 upon 8. So 39 upon 8 will be your result. So this is what you have solved it using the distributivity of rational number. If you do addition of 5 upon 2 and 3 upon 4 and then you multiply with 3 by 2, your result would be same, that is 39 upon 8. Now next we have here the rational numbers can be represented on a number line. We know that how to represent the natural number on the number line, whole numbers, integers. So if this is a number line and you want to put the integers on it, so this is 0, we have 1, 2, 3 and we keep on moving on the right side. Then we have minus 1, minus 2 and minus 3 and we keep on moving towards the left side. This is how we write. But what about the rational number? How we can represent it on the number line? Suppose I'm going to represent minus 3 upon 4 on the number line. So this minus 3 upon 4 on the number line, how can I represent it? So if I have a number line, first I need to look at the denominator. This is 4. So this can be written as minus 3 into 1 by 4. So 1/4. So 1 got divided in 4 equal parts and then it is 3 times. So if you take 0 here and you take your 1 unit in 4 equal parts, so you will write minus 1 by 4, minus 2 by 4, minus 3 by 4, minus 4 by 4. So this is minus 4 by 4 here. That means minus 1. So your 1 unit got divided in 4 equal parts, and you need to represent minus 3 by 4 on the number line. So this is minus 1 by 4. This is minus 2 by 4, and this is minus 3 by 4. So this is how we represent the given number on the number line. So this is the point A that is represented on the number line. Similarly, on the right side you can have here 1 by 4, 2 by 4, 3 by 4, and then 4 by 4. So this is what you represent your number line with the rational numbers given to you, right? Minus 3 upon 4. Now any other example, if suppose that you are supposed to locate minus 7 upon 5 on the number line, so you will take 5 equal division of the 1 unit. 1 unit means here any one fixed length. So 0 to minus 1 is a fixed length. We don't compare it with centimeter, we do not measure it with inches or foot. We simply say that this 0 to minus 1 is 1 unit, and that got divided in 4 equal parts. Similarly, you need to take 5 equal parts of 1 unit, right? And then you need to keep on moving the 5 equal parts of the another 1 unit, minus 1, 2, minus 2, and then you will keep on writing the numbers in negative. If you have 0 here, we don't require the positive numbers, so we write minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, minus 5 by 5. So this is minus 5 by 5, and this is minus 1. 5, we got 5 equal parts of the one fixed unit. Now minus 6 by 5 and minus 7 by 5. So this is the number minus 7 by 5 we have to represent here on the number line, and this can be represented as the point B here. So this is what happens in case of presenting the rational number on the number line. You need to focus on the given denominator and make that equal parts of the given unit, and you represent it on the number line. So I hope you have some clarity now how to represent the number lines with rational numbers. Now next we have between any two given rational numbers, there are countless rational numbers. The idea of mean helps us to find rational numbers between two rational numbers. So on a number line, if you talk about a number line, in this case we have 0, 1 unit, 2 unit, 3 unit of any equal fixed length, then minus 1, minus 2, minus 3. In this case we have the various numbers between the two given numbers. So 1 and 2, between 1 and 2 we have various numbers, countless, infinite numbers we have. So given two rational numbers, we have countless rational numbers between the two. How we find it? We find it by adding the 2 and dividing it by 2. Suppose that you have a number 1 and 2, these are the rational numbers. 1 can be written as 1 upon 1, 2 upon 1. So between 1 and 2, if you want to find a number, so 1 plus 2, you add it and divide it by 2. So this is 3 by 2, and this is somewhere in between 1 and 2. This is 3 by 2. Similarly, if you want to find the rational number between 1 and 3 by 2 here, so you add 1 with 3 by 2 and then divide it by 2. So in this case, you will get a number between 1 and 3 by 2. So your addition is here 5 by 2 and divided by 2. So here we get 5 upon 4. So this is what the number between 1 and 3 by 2, 5 upon 4. And we keep on doing the addition and division by 2. We also use the concept of equivalence. We find the equivalent rational numbers if we are supposed to find more than one rational numbers between the given two rational numbers. You take the equivalent rational numbers and then you find it using the concept of equivalence. Suppose that you have been given two rational numbers, that is 5 upon 2, and another rational number you have been given, that is 7 upon 3, and you are supposed to find 5 rational numbers between these two. So you take LCM of the denominator and you make the equivalent rational numbers of 5 by 2 and 7 by 3, and then you get the required number of rational numbers between the two given rational numbers. So concept of equivalency we use there. But in case of finding one rational number between the two, you just simply add it and divide it by the value 2. You will get the exact middle value of the given two rational numbers. So as we have got here 3 by 2 between 1 and 2. Now next, thank you everyone for watching this video. Please like, share and subscribe the channel.